Now let us understand the principle behind the cyclotron works with the help of this small diagram. So this is a magnetic field and this is a electric field, and here the magnetic field is perpendicular to electric field, and here there is a charge particle. The purpose of using this perpendicular magnetic field is to make that charge particle to go in a circular orbit. When this charge particle made to pass this electric field again and again, or made to cross this electric field again and again with the help of the strong magnetic field, this charge particle can be accelerated, and when taken out that charge particle from the cyclotron, it will moves with very high velocity, and high velocity means that possesses very high energy. Therefore cyclotron is a particle accelerator. Now let us see the different applications of a cyclotron. As we know, the cyclotron is a particle accelerator which gives the high energetic, high moving beam of particle, and that high energetic beam of particle used to start nuclear reaction, to study nuclear structure, to study and understand various different nuclear properties. Again, this high energetic particle which come out from the cyclotron, that can be used to modify the surface of the any material. It is also used to understand the structure, the dynamics and the different properties of the material, such as its physical property, its chemical property, its biological properties, and even its medical properties. Then another important use of this one is the high energetic beam of particle that can be bombarded on some material, and that specific material is converted to medical isotope, and that is used as a medical drug to treat, diagnose and detect a cancer. Even this is also used for sterilization, and in advanced medical field it is used in medical imaging procedure. So these are the various different applications of a cyclotron. Here in this diagram you can see there are these two parts are called Ds. Why they are called Ds? Because they are look like a shape of capital letter D. So here it is, this is look like a capital letter D, and this is here another one D, that is inverted of capital letter D. So that's why, because of their shape, they are called the Ds. Now let us call this D as D1 and this D as D2. Now what's their shape? They are semicircular. So here you can see they are semicircular. So they are semicircular. They are flat, and inside they are completely empty. So they are hollow. They are made up of metal. So that's why they are also called as metallic chambers or boxes, and they are placed horizontally, keeping their diametrical edges are parallel to each other. So here in this diagram is horizontally and diametrical edges are parallel, and there is a very sharp gap between these two. They are placed with a small distance, so having very sharp gap between these two, and these cross these two Ds connected with a high frequency alternating current source, that is alternating voltage source. when it is connected to a high frequency alternating voltage source, these two Ds also act as a electrode, and this entire arrangement is kept in a vacuum. That means these two Ds are completely evacuated, they are kept in a vacuum. Another one thing is, above and below to these two Ds, two strong electromagnet are placed. Say as in a below there is a electromagnet of north pole, and there is a above to these two Ds there is another electromagnet which is of a south pole. So which will produce the uniform magnetic field, and that uniform magnetic field is perpendicular to plane of Ds. So here in this diagram you can see, so here there are the two electromagnet, correct? So this is a north pole, this is a south pole. So magnetic flux lines from north to south pole, and this will give uniform perpendicular magnetic field. And at center the ion source is kept. So what ion source? That may be any heated filament, or it may be any radioactive material, radioactive substance which gives the electrons, protons, or heavy particles as in deuterons. So that ion source which is kept at the center. This high frequency alternating source which have the capacity of producing near about 10 to the power 4 volt. The high frequency alternating source, which is also called to be an oscillator, which can produce the voltage of 10 to the power 4 volt, and its frequency is very high, which is of the order of 10 to the power 6 hertz. That is, it can change its polarity a million times in a second. You can say it can change near about 1 lakh times per second. It can change its polarity 1 lakh times in a second. So that is very high frequency alternating voltage source which is connected across these two Ds. There are the two deflecting plates E and F, where a small electric field is applied, and here it is a window W, from which that accelerated particle can be taken out by applying very small current to these two deflecting plates. So this is all about the construction of cyclotron. This is ion source. This is high frequency alternating source is connected across D1 and D2. Suppose at any instant of time the ion source gives rise to positively charged particles. Suppose at that instant D1 is at negative potential and this one is at positive potential. Now when it is at negative potential, it will be act as a negative electrode. Now here from this one the positive ion will come out, and that positive ion is accelerate towards D1. Now as we know, suppose there are the two electrode, positive electrode and negative electrode. In between they are having some potential difference, and electric field it is in this direction, that is E, and suppose a positively charged particle having charge Q and mass m, and when it is in a electric field it will experience a force, and that force which is equal to that is charge on the particle and strength of electric field, and this charged particle will accelerate towards the negative electrode with a acceleration, and that acceleration we know, which is equal to A is equal to F upon m. Now force experienced by this charged particle is Q upon E, therefore this is Q E upon m. So this is a acceleration with which that positively charged particle will accelerates towards negative plate. So here this positively charged particle accelerates towards D1, go inside D1. Now inside D1 it not experience any electric field, but it experience the perpendicular magnetic field, and perpendicular magnetic field will make it to go in a circular orbit. So this particle go in a circular trajectory with a constant speed, and when this positively charged particle arrives, the gap between the two D's polarity is a reverse, that it become positive and it become negative. So again here in this case, this is a positive electrode, this is negative electrode, a charged particle with charge Q, it will be accelerate towards negative electrode with acceleration and in this gap it will be speeds up, it get additional energy, go inside D2, it will be transverse circular path. Again when it arrives, the gap between the two D's, again polarity is changes, it become negative and it become positive. Basically like the strength of magnetic field and frequency of the alternating potential is adjusted in a such a way that whenever this particle arrives in the gap between two D's, polarity is reverse, or we can say the frequency of the particle is same that of frequency of the alternating potential. That means the frequency of the particle and frequency of the alternating potential are in phase. That's why sometimes the cyclotron is also called the magnetic resonance accelerator. This is negative, this is positive, so again this situation arrives. Therefore when this positively charged particle arrives in this gap, polarity changes, again in this gap it get additional energy, it speeds up and moves with greater speed, go inside D1, not experiences any electric field, experiences a magnetic field. As a result it will transverse circular path with a larger radius than that of previous. So it is in this fashion and this process continues. So thus a positive ion accelerating each time at it crosses the electric field again and again and it will transverse with a greater and greater radius with greater and greater speeds. So whenever it arrives in the gap, crosses electric field, each time it receives impulse and get additional energy and it will be accelerated in this way. A positive ion accelerating as it comes in the gap between the D's, that means it accelerating each time as it crosses the electric field. The increase in the semicircular path is actually compensated by increase in its velocity. The most important thing which we should have to remember is that suppose for a positive particle to go from here to here, from here to here, or from here to here, or from here to here, let it call it as t, or that same t is also for here, that is time taken by positive charge particle to go from here to here or from here to here, we have denoted with t. Then whenever that particle arrives in the gap between two D's, polarity must be reverse. That means this time taken by that particle to transverse semicircular path is should be equal to half of the time period of alternating potential. So this condition satisfied here. So as long as strength of the magnetic field and frequency of the alternating potential is adjusted properly, this remains same until the charge on particle and mass of particle remain same. Now finally the accelerated particle with sufficient velocity, it can be taken out by applying small electric field to these two deflecting plate E and F. Therefore this particle accelerated and taken out from the window W. So this charged particle will come with high velocity, and this particle or beam of particle is very high energetic. While explaining the working mechanism behind this cyclotron, we have seen the charged particle move under the influence of magnetic field, and that magnetic field is perpendicular to plane of D's, correct. Now that can same we can visualize by this diagram. So here this is a region where the electric field exists. So this is electric field and magnetic field which is perpendicular to the plane of D's. So this is a magnetic field which is perpendicular to plane of D's. That's why here the magnetic field and electric field are also called as cross fields. Now let us see the theory behind the cyclotron. As we know, the positively charged particle which is come out from the ion source, whenever a charged particle move in a perpendicular magnetic field, it experience a force, and magnitude of that force is given by Lorentz law, and that magnitude of that force experienced by positively charged particle moving under perpendicular magnetic field is given by F is equal to Q, B and V, where Q is the charge on that particle, B is the strength of magnetic field, and V is the velocity with which that particle is moving. Now that force will make that positively charged particle to move in a circular orbit, correct, and that force is it experiences a centripetal force, a force which is always directed towards the center, and that centripetal force we know F is equal to, that is m v square upon r, where m is the mass of that positively charged particle, v is the velocity with which that particle is moving, and r is the radius of that circular orbit. Now comparing these two equations, we will get, that is q b v is equal to m v square upon r. Let us solve this equation for v. We will get this equation for v as, that is q b r upon m is equal to v square upon v. So, we will get v which is equal to qbr upon m. So, this is the expression for velocity with which that particle is moving. Again, if we solve this equation for r, radius with which that particle is moving, we will get this equation as r is equal to mv upon qb. V is equal to qbr upon m, expression for velocity with which that particle is moving, and r is equal to mv upon qb, that is radius with which that particle is moving. Now, let us find the time taken by that particle to traverse a semicircular path, that is from here to here or from here to here. Let us denote that time taken by that particle to traverse a semicircular path is t. Now, as we know, that is time is equal to, that is distance upon speed. Now here distance, we are going to calculate the time taken by that particle to traverse a semicircular path. For a circle, we know circumference is 2 pi r, and for a semicircle it is pi r. So, we can write it as t is equal to, that is pi r upon speed with which that particle is moving is v. Now, let us substitute the value of r from this equation. We will get this is equal to pi v into mv upon qb. So, v get cancelled, therefore, t we will get it as, that is pi m upon qb. That means this equation is most significant, which tells that the time taken by that particle to traverse this semicircular path to here or here to here or here to here, or with a larger radius from here to here, or time taken by that particle go from here to here or with a larger radius from here to here, is same and is not at all depend upon velocity with which it is moving, and even it is not at all depend upon radius with which it is moving. That equation means the time taken by the particle to traverse any semicircular path is same. That means a particle with a smaller radius moves with a smaller speed, a particle moves with a greater radius with a greater speed. Until what that time remains same. If you are going to divide m to numerator and denominator, we will get t is equal to pi upon b q upon m. That equation means until the charge upon mass ratio of a positively charged particle remain constant, till then the time taken by that particle to traverse semicircular path is remain constant. Now, let us find the resonance condition. What is a resonance means? When the frequency of the alternating potential is equal to the frequency of the particle in a cyclotron. If both are equal, then it is said to be they are in a resonance. They are resonance, it means, that means whenever the particle arrives in the gap between two D's, polarity is a reverse. If the resonance is there, then only that particle, frequency of the particle and frequency of the alternating potential are in a phase. Now, let us find the expression for that one. As we know, the time taken by that particle to traverse a semicircular path, that is t, which is equal to, exactly equal to half of the time period of the alternating potential, or we can write it as t, that is time period of the alternating potential, which is equal to 2 times time taken by the particle to traverse a semicircular path. Now, as we know, the frequency is equal to 1 upon, that is t, 1 upon time period is gives frequency. Now, this is equal to 1 upon 2t. Now, this t value just now we have solved and we got t is equal to pi m upon qb. Substituting this value, we will get this as 1 upon 2 pi m upon qb, and simplifying we will get f is equal to, that is qb upon 2 pi m. Now, this is the frequency with which that particle is moving in a cyclotron, correct. Now, let us consider f naught. F naught is the frequency of the alternating potential, and we are saying the frequency of the particle and frequency of the alternating potential are in a phase. That means they both are same. Therefore, we can write, that is frequency of the alternating potential is equal to frequency of the positively charged particle moving in a cyclotron, which is equal to qb upon 2 pi m. If this condition satisfied, then only they both are in a phase. That means whenever that particle arrives in the gap between the two D's, it receives impulse, get additional energy, speeds up and goes in these D's and moves with constant velocity and so on. So, by this way that particle go on accelerating, speeds up, getting more and more energy, moving with more and more speed. Now, let us find the kinetic energy with which that particle is coming out from those D's. Now, as we know, the kinetic energy, that is Ke, is equal to, that is half mv square, velocity with which that particle is comes out. Now, we have just now got the expression for velocity, that is v. Now, substituting in this equation, we will get this is half m, this is q b r upon m, this is whole square. So, m get cancelled, therefore, this expression is half q b r bracket square divided by m. So, this is the kinetic energy. Suppose this is the maximum radius with which that particle is moving, and from here we have taken out that particle. Let us denote, that is maximum radius with which that particle is moving. Therefore, it will be, this is the maximum energy with which that particle is coming out. Let it denote as Em, that is E max, which is equal to half q b r bracket square. So, that is moving with maximum velocity. So, we can write it as r max divided by m. So, in case of cyclotron, we have expression for v is q b r upon m, the radius with which it is moving, that is mv upon qb, time taken by that particle to traverse a semicircular path, that is t is equal to pi m upon qb, and that time remains same until q upon m ratio remains constant. The resonance condition, that is frequency of the particle is equal to that of the frequency of alternating potential, and frequency of alternating potential, how much we should have to keep so that if that particle is in phase with frequency of alternating potential, that is bq upon 2 pi m. The maximum energy with which that particle is coming out from the cyclotron is E max is equal to half in a bracket QB R max whole square upon M. The shortcoming or the limitations of a cyclotron. As I have discussed, in a cyclotron we can accelerate a positively charged particle such as protons or deuterons, but up to a certain range. As proton in a cyclotron is moving with a very high velocity, say that of the 50% or 60% that of speed of light, its mass increases. According to theory of relativity, that m is equal to m naught upon square root of 1 minus v square upon c square, where m is the rest mass of the proton, v is the velocity with which that proton is moving in a cyclotron, and c is the speed of light, and m is relativistic mass of proton. When its speed is equal to 50% or 60% that of speed of light, its mass increases, and as mass increases, the time taken by the particle to reach in a gap between two D's is increases. That means the particle take a longer time to traverse a semicircular path. So particle may be here and polarity will changes. So as a result, that particle in a cyclotron will not be no longer in a phase with alternating potential. Therefore, proton can at most we can accelerate to energy 40 mega electron volt, and that of deuteron, which is heavier than that of proton, so it can be accelerate up to 20 mega electron volt. The second limitation is the negatively charged particle, say as an electron, which is much a lighter particle. The electron in a cyclotron, when it approaches to energy of say as an 1 mega electron volt, its speed is nearly equal to 90% of speed of light, and at that higher speed the mass of electron is 2.5 times that of the rest mass of the electron. As a result, mass increases, again time taken by that particle to reach in a gap between two D's is increases. As a result, within a short interval of time, it will lose the phase condition with alternating potential. And third limitation is we cannot accelerate a neutral particle in a cyclotron, say neutral particle as a neutron, because it cannot interact with electric field and magnetic field. So we cannot accelerate neutral particle in a cyclotron. Thank you.